Now that we've installed the underlayment in the pitch transition area, we need to go ahead and install an offset cleat so that we can clip our panels into it. But before we do that, I want to have a quick conversation around when to use sealants and when not to, such as butyl tape. So here at the eave, we don't want to trap water and moisture that might be sitting on top of the underlayment behind the cleat. We want that condensation or water to flow underneath the cleat and into the gutter. So in this case, I'm not going to use any butyl tape, and I'm going to install the cleat using a panhead screw, knowing that my fastener is going to thread the sealant of the ice and water shield. And what that does is allow for moisture and condensation that's on top of the ice and water shield to exit the roof. There are plenty of occasions when we do need to use sealants, when we want to keep water from backing up, but we never want to impede water from flowing downslope and exiting the roof. Now that I'm ready to install a panel in the pitch transition area, I'm going to do my calculations for my starter panel, making sure that I give myself enough room in my calculations that I can turn the panel up 90 degrees, a couple of inches along the sidewall detail. So I'm going to go ahead, take those measurements, and then we can start bending and installing. The panel that I have on the table is the first panel that we're installing in the pitch transition area, and it's also the panel that is going to be running alongside the sidewall. So what I've made is I've made a measure as to how much of the pan I want on the roof deck, and I'm giving another 3 inches that I'm going to turn up the sidewall. So I'm going to go ahead and cut it using the Malco turbo shear, and then I'm going to bend it in the bender, and we're going to go ahead and install it. I have my starter panel for the pitch transition area. You can see that I've bent up the panel 3 inches to walk up the sidewall. I'm now going to finish the end so that I can clip into the offset cleat, and then we can go ahead and install it. The first panel in the pitch transition area has been installed. I've hemmed it at the bottom and clipped into the offset cleat. We will be installing an overflashing, but it's always necessary to turn the panel up the wall as much as we can. In this case, I've done 3 inches. At the top of the panel, I've done a bread pan fold, just in case there's anything windblown that gets pushed behind the Z-trim. It keeps it from rolling into the roof. I need to install the second lower panel so that we can go ahead and flash the transition and then install the upper panels. So in both cases, the start panel and the finish panel, because it's such a small section, need to be sheared along their length. So I've just taken my measurement from the inside of my rib to the rake, and it's square. So I'm going to cut that, fold it up 1 inch, and install it. The second panel is ready to be installed. I've done a 1 inch hem at the bottom to be clipped into the offset cleat. I've turned it up 90 degrees along the rake, and I've put a bread pan fold in the transition area as a second line of defense against anything that gets blown behind the Z-trim that we're going to use, or the foam closure if that's what you're using. So I'm going to go ahead and install it. And a little trick here is you can see that we've got the offset cleat, but because there's ice and water shield underneath it, it gets a bit sticky, so I'm installing just a piece of scrap flat stock so that I can easily slide my panel in. Now that I've made my cuts on the Z-trim, I'm going to go ahead and install it, but first I want to talk about the use of sealants. In this case, we've used a bread pan fold that does not allow any water to roll over the top of the panel and into the roof. And there's no question that when you have a low slope, high slope transition in the North Country, you're going to have snow and ice sitting on this transition piece and pushing back against it. If you're not going to use a bread pan fold, it's important that you use sealant on the bottom of the Z-trim, as well as where the Z-trim meets the walls of the panel. Otherwise, water is going to get pushed in there and enough of it will spill out over the back of the panel and into the roof. Yes, it's going to go onto the underlayment, but if there's a tear in the underlayment, if there's a cut, a corner, you could wind up with a potential for leaking. In the case where you're using a bread pan fold, I'm not going to use any sealant because I want whatever gets pushed back here to be able to exit. We know that it's not going to roll into the roof because it's hitting the wall of the bread pan. And by not using sealant, we allow it to roll back out and down the roof panel. So I'm going to go ahead and install this. With the Z-trim installed, now we can go ahead and install the transition flashing. It's important that we turn the transition flashing up the sidewall in the same way that we turned the panel up the sidewall, so that when our overflashing comes, we have a good amount of protection for what is absolutely going to be an area where a lot of snow and ice accumulate. So I'm going to take my measurements to just turn this up the wall, and then we're going to come and install it. I've prepared the transition flashing. What I've done is I've walked it up the sidewall 3 inches, and I've turned it over the rake by 1 inch or 1.5 inches. So now I'm going to install that by sliding it and clipping it into the Z-trim. I'll use a couple of fasteners along the top, and then we can install an offset cleat and run our top panels. I'm going to install the transition flashing now. I just want to point out that in this case, given where the snow and ice load is going to be sitting and pushing back, and the fact that we don't have any secondary backup, I've used 2 rows of sealant, and I'll make sure that my fasteners thread one of those rows. And I've spaced my fasteners relatively close, just given the fact that I know that this transition area is going to be under a lot of pressure, a lot of push and pull from snow and ice load that sits here before it exits the roof. Now I'm going to go ahead and take the measurements for the upper panels for the higher slope. It's going to be the same principle. We're going to walk them up the wall 3 inches and do a 1 inch bend up along the rake. So I'm going to go ahead, prepare those panels, we'll come back and we'll install them. Same process. I've turned it up the wall 3 inches. The only difference is that here we're clipping into the offset cleat on the transition trim instead of at the eave. I'm going to go ahead and install that now. Now I'm going to install the second panel. I'm going to clip this into the offset cleat, and I want to point out one feature here is that I've used a bread pan fold, but because we have a vented ridge, I haven't gone the full 1 inch because I don't want to block air flowing in and out of the attic space. So I've turned it up just about a 1/2 inch, again as a secondary backup against wind-driven snow and rain, and go ahead and install this. What we've been working on here today is the pitch transition. It's very similar to what you're going to find on a gambrel roof, where you have a low slope and a high slope coming together. Very similar, same approach, and you can use it for that detail as well. As a quick wrap-up for our pitch transition section, I'm going to point out that we have a low slope coming together with a high slope. We have a pitch transition flashing here that joins the 2 sections and makes sure that snow and ice that collects here isn't able to enter the roof. At the bottom, our panels are clipped into an offset cleat. I haven't used any sealant beneath that offset cleat because I want any condensation that could potentially form between the metal and the roof deck to exit the roof. Our panels walk up the sidewall 3-4 inches. We have a 90-degree bend up at the rake because of the rake detail that we're going to use. And our upper panels clip into an offset cleat where I have used butyl tape beneath so that anything that pushes back up can't get into the roof. And at the top, we have a 1/2 inch bread pan fold because we have a vented roof section and we don't want to use a full bread pan, which is going to slow down, reduce the airflow in and out of the attic space. Thanks very much for watching, and if you have any questions, please reach out to your All American Steel rep or shoot us a note through social media.